Some students did pages and pages of unnecessary working for this question. Let's make sure it doesn't happen to you in your A-level exams this summer. In the report after the exams, the examiners said that students scored a mean mark of only 2.1 out of 6 points. It was a very mixed response. They said it was disappointing to see how many candidates got bogged down in pages of algebraic working. Really, it can be answered very efficiently. Let's see how. Figure 1 shows a sketch of a curve c, y equals f of x, where f of x is a cubic expression in x. It says the curve passes through the origin, it has a maximum turning point at 2, 8, and a minimum turning point at 6, 0. It says write down the set of values for which the gradient, f prime of x, that's dy by dx, is less than 0. So that's talking about parts on the graph where we have a negative gradient. So if you imagine drawing a tangent to the curve at various points, over here the tangent would have a positive gradient. At the point 2, 8, it would have 0 gradient. In between here it would have a negative gradient, and at 6 it would be 0 gradient, and then it would have a positive gradient. So where does it have a negative gradient, as it says here? Well, between the x value of this turning point here and this turning point here. In other words, between 2 and 6. Do we include 2 and 6? Well, no, at 2 and 6, the gradient is 0. So these need to be strict inequalities here. We need to be careful about that. It says the line with equation y equals k, where k is a constant, intersects the curve c at only one point. Find the set of values of k, giving your answer in set notation. Let's think about what a line y equals k would look like. Well, it could be something like, I don't know, y equals minus 2 or y equals minus 4.3. There's all sorts of different lines, but they're all horizontal lines. So what we've got here is a family of horizontal lines. Let's draw a horizontal line down here. This would be our line y equals k, and of course, where it intersects the y-axis would be at the point k here. So this position, you can see as I've drawn the line here, it's only intersecting the curve once. But if I increase the value of k, well, it's still only intersecting once here, but you see at this point, as soon as it meets the x-axis, then it's actually intersecting just for a moment, twice, here and here. And then if I increase the value of k further, you can see, for instance, at this point, it's intersecting at 1, 2, 3 distinct points. And if I increase it further, still 3, until we get to this point here. And you can see at that point, once again, it's intersecting exactly twice. But if I increase it further, you can see then it only intersects it once up here. So remember, we were looking for the line to intersect the curve at only one point. So I either want the line to be above this point, or I want the line to be below this point. What's the equation of this line here? Well, that's the line where the y-coordinate is 8. So this line would be y equals 8. And I'd really want the line to be above that. So one possibility is that I want k to be greater than 8. But the other possibility is that I want the line to be below this line. In other words, below the line that passes through 0, y equals 0. I really want the line to be down here. So the other possibility is that k is less than 0. But be careful. That doesn't get us full marks because the question said to give your answer in set notation. So how do we write that in set notation? Well, we have to use set brackets. These are these curly brackets that we have here. We say k such that k is less than 0. And then we have a separate set of curly brackets here. K such that k is greater than 8. Not equal to 8. We've got to be careful. These are strict inequalities, right? And we need to be really careful about the symbol we put between. It needs to be a union, not an intersection. If you put that, it would be marked as wrong. Because we want this to happen or this to happen here. Not both at the same time, because that's impossible, right? K can't be negative and greater than 8 at the same time. It needs to be a union. Part C, find the equation of the curve. You may leave your answer in factorized form. So what kind of graph is this? Well, it's a cubic expression. And I can see from the shape of the graph that it's going to have a positive coefficient of x cubed, because the graph goes this way rather than this way. What else can I deduce about the equation? Well, it passes through x equals 0 here, and it just touches at x equals 6 here. So x equals 0 is what we call a single root, whereas x equals 6, because it's just touching, the curve's just a tangent there, it's called a double root. And that means something important about the equation. It means that we're just going to have x here, that corresponds to this point, but we're also going to have an x minus 6 bracket, but that's going to be squared because this is a double root, it's a tangent. Notice that if you were to set y equal to 0 and solve the equation, we'd end up with two solutions. X equals 0 and x equals 6 would really happen twice because of this square here. But there's something else we mustn't forget. There are all sorts of different cubic graphs that could pass through those 2 points I've highlighted, all with slightly different shapes. So for example, the one that I've drawn here could be another one in the family. So all of these graphs have been stretched vertically. So I need to take that into account by including a scaling factor here. That's going to stretch the graph vertically parallel to the y-axis. And I'm going to need to work out what this number is, this fixed constant a is. How can I do that? Well, what information haven't I yet used? It's this point here, the point 28. I know that when x equals 2, y equals 8. So I can substitute those into the graph. When y equals 8, x equals 2. So I can replace each of the x values in this equation by the number 2. 2 minus 6 is minus 4. And then if we do the number crunching, 2 times 16 is 32. And if you solve for a, you get a equals a quarter. So if we replace a back into the equation I wrote down in the first line, a equals a quarter, we end up with this. And we can leave this in this form because it said that we can leave our answer in factorised form.